Hey, it's Brian here from quantlabs.net. Today I'm going to show you, after learning quite a bit about Stateflow, Simulink, where both tools within MATLAB are at in 2015, I can say that it's come a long ways. The primary example I wanted to show you is already available within MATLAB when you download it or buy it. There's some examples. This particular one I want to show you is concerning parallelization using par4 parallelized for loops instead of the standard for loops that are used. It's going to walk you through the process. It looks like it can be highly integrated with Simulink on top of building out some pretty interesting charts. I'm going to add on a few thoughts at the end of this. So if you come to this website, I'll put it in the posting, my blog. So basically what it's doing is just recording the pitch and roll in cars. Okay, Simulink is used for a lot of industry type of uses. So what you got to do here is you got to set up a model, local model. This is again available as standard model example in MATLAB, and then also here you just open up the model, which is basically the Simulink, which is this guy. I'm not going to run this because it takes a bit of time to set up, but the big thing is one beautiful thing about MATLAB is the ability to parallelize based upon how many workers you make available to the install of your MATLAB. It's fairly easy. Right here it's only 4 lines, so what you're going to do here is you're going to set up a pool of MATLAB workers. Now this is probably the most expensive part of MATLAB, but if you have a high-end server, an 8-core with, I don't know, a couple of gig of RAM, you could easily put your workers on that. You can cluster them together and you can virtually do things pretty powerful in a simulated, not a simulated, but a real cluster, and it's set up quite easily. I'm not here to show you that, but what I will show you is MATLAB. Once you run your pool, like here, it will start up the pool, and it gets started right here. So I can easily shut down the parallel pool, or I'll just show you some of the parameters here. So you do have some availability. I'm running this locally on i7, 12 gigs of RAM, so it's not very smart, but I'm sure that this can be expanded once it can see a cluster of or MATLAB pool of clusters of other MATLAB workers. So that is available, and that is very easy to set up. I've seen how it's done in raw, Java, C, even Python. R is pretty good actually with do Redis, but it's not taking advantage of actual processors as easily. Okay, so what we then do is we need to set up the model, and what we have here is it builds out a target for this thing called a rapid accelerator. I think because you basically build the model, meaning you're going to run some kind of code generation process, so build out a new target. So next time you run this, it's already ready to go. It's already pre-allocated, and it will speed up your simulations quite quickly. I'm not here to show you the difference, but I just want to show how easy it is. It does run. It will build out that new target, and then of course you open up the model, as you can see here. On top of that, what you can do is you can see this time and time again with a lot of the MATLAB demos, webinars, is run these parameter sweeps. I'm not sure using like fully understanding it as of yet, but I just wanted to show you, once you build out your target, you can easily interface it with your Simulink model, and then be able to process it and be able to run it really fast with all these commands here. And it runs pretty quickly. I think We are dealing with MB sweep, so this runs no problem. And then what we do is we run another simulation, the actual simulation itself, in a par 4 mode. As you can see here, because we're running a for loop of iterations. Let me see how many iterations we're dealing with here. So we got 10 iterations, not many, but it's running those in parallel. And again, you could probably run it really fast on a good high-end server. So that runs no problem, as you can see here. And then what we do is we build out a result loop, the result plot, which is here, and it runs fine, exactly as you would expect. And then what you can do is you can obviously tear down the MATLAB pool of all the workers, which I can probably run right now. And so it's going to tear everything down. And there you go, it's just shut everything down. No parallel pool. So all in all, I just want to show you how easy it is to use parallelization within MATLAB. As I said, it is one of the most expensive parts. You can also easily integrate it into Simulink models, which is a big deal. I would imagine if you were to run this in a production environment, you could probably do the same thing, meaning a live trading system. I have to verify that as I get closer to it. As I said, also, I've gone through some of the demos on MATLAB. Let me just pull up my blog here. Give me a second here. Because what I want to show you is the other amazing thing about MATLAB is the ability to go through the live webinars from a few years ago that can showcase some of the capabilities of Simulink and Stateflow, and of course MuPad as well as part of that. What I'm really amazed with is that I have talked about in the past using MATLAB Guide. This particular demo here enables you to basically run your Simulink model and session, but you can also use Guide as a way to interface all your data. Instead of me showing you the little knobs and the gauges and all that, you can also do it right within the MATLAB Guide, which I kind of knew, but I just triggered my memory there. So that's a pretty powerful capability. Also, another big thing is with the Simulink webinars that I posted. As I said, I posted 2. This one is about processing, signal processing and communication, you know, like cable TV or Bluetooth. That's what it's really used for. But just examples of some of the capabilities that you can get with Simulink. Knowing that, another big feature is with MATLAB, when you're building out MATLAB functions, one of the nice things about it is you have 2 action languages within a Simulink model. You can obviously choose MATLAB scripting, or you can actually use C. Let me repeat that. You can actually use C. So you can build out some very powerful C functions, both within the Simulink, specifically the Stateflow or custom. I also know within Simulink you can build on initiation when it loads up the Simulink model. You can run C functions. You can also run C functions at the end of the simulation, which is very powerful. Another big feature that Simulink has, I haven't really ventured into it a whole lot. I haven't ventured into all the Simscape S functions. S functions are C functions that you can interface with Simulink. So there's a lot of very big, powerful things coming out of this. Not only that, with Redis and handling of data, there's 2 real options I have. Because I'm going to start using Redis as probably my database of choices as an in-memory database, the nice thing about using Simulink is the ability to put in placeholders within my Simulink model, saying if I want to request data, I can put a placeholder there. if I want to do something with a database from Redis, I can put a placeholder in there, and then I can have stubby C code, and then be able to plug that into the final set of code that I'm working with on the Simulink trading model, if you want to call it that. So there's that. I'm also learning through the Simulink blogs from a variety of people that you can use on initiation as part of the inflow. You can use jar. It will interface with jar files. So that's a very powerful feature due to the fact that it's, let's say if you want to go live, there's maybe some potential that if I use interactive brokers or any broker that supports Java, I'll be able to use those provided jar files, and that would obviously include the API. So maybe I can interface that with my own jar files and then have them deployed as part of the the Simulink model. So there's a lot of powerful features here. On top of that, the other big thing that I'm really digging is this features model or system, we'll call it that. So the first model I'm looking at to do is hedging. I've already put a little blurb on that, why hedging and why focus on hedging as a start. In the book that I've gone on about from Colin Carter is with chapter 7, which focuses nothing but hedging, which really is meant for obviously people that are owners of commodity or writers of options. Now, if you're a writer of options, you have some good statistics working in your favor, because over 80% of all options expire worthless, which basically means that if you're going to start playing in the world of options, you got a 20% chance of profiting. So those kind of odds, hedging may be somewhat to an advantage. I don't think it'd be very useful from the get-go. I know that. I just realized that to really venture into the world of Simulink and Stateflow, and even with the MuPad, and with the C, and throw in all the plotting that I want to do with the Java jar files through MATLAB Guide on top of the Redis with the C database, I think this is a really good test, proof of concept you can call it, to be able to bring everything all together in one model, build it in Simulink, and use all the different other tools like Stateflow and probably the MuPad as well to build out the proper algorithms. I've already done 50, but some of them are a little kind of questionable. So there's a lot of cool things coming out of this, and I'm really excited to be able to deploy it, because now I have the technology and the workflow in place, and be able to take that and now take an actual real world trading scenario and build something with it. And again, I'm going to use hedging just as an example to see if this works, and actually try to interface it at some point with a database, specifically Redis, but things can change, as you know. All right, I just wanted to put that together. I wanted to make a point of a parallelization, just to show that MATLAB and MathWorks has put this product light years ahead of anything else that I've seen, and just being able to develop it really fast is pretty impressive. All right, talk to you later.